Okay, so we have ourselves a thing in three parts, right? So we will be installing Prometheus and we'll be adding it, well, basically installing Prometheus to our CTF on the ITOM platform, or call it whatever you want, and then monitoring it with Sitescope. So that's exciting. But the third part is something in the middle. Like, what do you do once when you need to connect those two bits? And I mean, installing it's easy. Monitoring is just, configure a monitor, but there are extra tasks that you need to do in the middle in order to expose it, and we're gonna do all three of them. So getting Prometheus and Grafana onto your CDF. First of all, we will be using Helm to install the packages and everything. So you need the Helm chart, and the Helm chart is something that you will download from the marketplace over here, because it's something that our R&D guys did. So we will do monitoring pack, and yeah, that's the one we select. There is another one that does practically the same thing, but it's a little bit it's not as generic. So this one is generic. It fits to all ITOM platforms. So you just click on download and you get it. So, but I already did this part. Now the second part, of course, is transferring the files to your master node, and let's do just that. Use whatever tool you want. I mean, I have my things, and you probably have your things. Right, so I'm just going to put it right here in my root directory. Okay, so that was easy. That was easy. As Bob Ross says, do whatever you want. Right. So now we'll do a little bit of a Helm installation. So Helm is like a package manager, let's say, or installer or app manager thingy repository for Kubernetes applications. Okay, so Docker run is for Docker, and for Kubernetes there is no kubectl run that we know of, right? kubectl is a bunch of YAML files, so Helm does it for us. So this is it. This is how you install Helm. It's done, and it's so fast because it's not an engine or something. It's just a thing that downloads a bunch of YAML files and executes them versus Kubernetes. So we're not even sure that it works. So just want to see what Helm version I got. 3.2.4. Okay, fantastic. So uh, let's see what's inside. So I'll go to ITOM monitoring. Oh, come on, monitoring. What? Not allowed to go inside. Did I unzip it? Did I? Right. No, I did not. So let's unzip it. And okay, better. So now we'll go to ITOM monitoring. Let's see what's inside. And there is like another. There is like another TGZ over here, which is okay. You know what? Yeah, that's okay. So now I want to see that all of my pods are up. I want to see if my Kubernetes is up because I started it not too long ago. So I go get pods. It will show me all the OpsBridge pods, and if they are up, I know that the ones in the core namespace are up as well. And yep, it's all running. I see that all statuses are up. So if I'll do it for core, this is where the Prometheus is going to go. It's actually, yep, it's all running and completed. So yeah, let's do it. Fantastic. So now we'll add a feature gate to our core over here, right? So just a command that puts Prometheus to the description of the CM. Okay, fantastic. And I need to delete one of the pods that corresponds to it. It's the management portal. So basically, I just run a command that wildcard selects it. And there is the manage portal, which is this one over here. And it's going to take it a second or so. Okay. So, and the funny thing is it takes it like 2 seconds to load, but yeah, sometimes when you delete the pods, but it just takes a little bit of time. I don't know, about 1 minute or so. And we are eager to run the next command. So let's skip the waiting part. And now when it's done, we'll do the next thing. So Kubernetes can generate download packages for the things that you need in private repositories, or at least the ITOM platform does. So there's like a command that you can run that would generate a download package based on the information available in the chart. So we specified the Prometheus operator chart, the custom chart that we downloaded previously from Marketplace. And when we tell the Kubernetes tools to generate download bundle, it would read the chart, see what it needs, and based on this information, it would create a download bundle that basically scripts that connect to private repository and download stuff for you. So it would take just another second for it to finish, and you might notice here a little dot. It's just because -d dot means that I put the output right where I am, because right now I'm in a specific location, and that's just a convenience. Okay, if you do it without -d, I think it puts it somewhere in the TMP folder or something, and then you need to go to one directory, another directory, navigate through one and another. It just becomes a little bit of a mess, right? So I want to maintain everything here. So there it is. This is my offline download, and I need to unzip it, unfortunately. Oh, unfortunately, I don't know. Depends on your current task at hand, right? And also, I'll unzip the Prometheus operator. Didn't I? Yep, didn't get it. So let me get the command. So I'll unzip or untar the Prometheus operator because it has stuff that I need. Okay, so I'm going to copy the image set. Image set is the JSON file that includes all of the images that you need for downloading. And apparently the one that we have in the chart downloaded from Marketplace is a better version of it than the one generated by the download package. Probably there is kind of a bug or something. So I'm going to override it because whatever the download bundle generator did is not good enough. So we need to make a little bit of a fixing. So I'll go inside and I need to edit this file. So here comes the funny thing. I'll need to provide several settings. So you know what, let me cut it and I'll show you. So several settings are missing. Okay, I need to specify what suite and which version. And in order to get the proper definitions of those things, we can refer to a couple of things. One of them, for example, is the installation, is the original download package that I used in order to install the ITOM platform in the first place. And we have a little bit of an axiom here, or a personal rule that I follow: never delete files unless you really have to. Okay, so those 200 kilobytes of offline download packages that I used originally to install the thing are still there. So let me show you. I'll go and I'll do cut, and then I'll go to root, and I think it was offline download. Yeah, yep, offline download, and then we're going to image set. So what it means, this is specifically the location where my previous download bundle for the whole CDF is located, and it has its own image set JSON. And when I read it, what I get is ops bridge, HPSW item, and a version. So you know what? I'm just going to grab the whole thing over here and copy it. Okay. So now in my new download image set JSON, I'll just edit it. Okay, so it's going to be image set JSON, and I'm going to remove those 4 lines, and I'm going to paste the ones that I copied from previous place, and I have a double one, so here it is, and that's it. So I use the previous file for something new, and it works fantastically. All right, so now we need to use the download images, so I'll do just that. And I'll do the download images SH, and I think I need to mention that it's going to be in the TMP. Oh, no, sorry. So I'm going to create a directory for it, directory for the downloads. Make it here. It's going to be TMP up. That's what's going to be its name. And then I'm going to download the images to this directory, so TMP up. Why? Because I want to control what I have and I want to put it in proper place. And also TMP folder empties itself after every reboot. So those files for sure I'm not going to use them later, because when you download images from a private repository, then you upload those images to a local repository. Now you have two versions of the same thing, right? So I'm not going to miss those images, and it doesn't go against my personal rule of not deleting things because they don't they don't contain custom data that I cannot get from other places. All right. So now it tried to connect to Docker IO, and I will need to use my personal password. So just use my last name and the password that you are not allowed to know. Let's see if I type it correctly. There it goes. Yep, I typed it correctly. So there is no need for us to wait all the time that it downloads things. Although it's going to be pretty fast. But still, let's skip that part. Okay, that was pretty fast. And by the way, if you follow the steps that I'm doing without talking like I do, it's like 5 minutes to get the whole thing. Okay, so now we need to upload images. Okay, so let's upload images from this directory of TMP app. Yes, I want to continue. We'll need to specify the repository, right? The password, just the password. So that's going to be the general administration password. And let's hope that I typed it properly on the first attempt. I think I did. So now it will take the files that it downloaded and it will push them into the local repository. So if everything works right, it should take about the same time as it took it for downloading, because the download was pretty fast. But we're going to skip this part as well. But maybe this is a good opportunity to explain what's going on. So using Helm, if you need to install Prometheus and Grafana, you basically just do Helm install Prometheus operator or something, and it just goes to the internet and downloads it for you and puts it in your repository. Well, unless you don't have direct access to Helm direct to Helm repositories, which you can add by adding a single command that says, well, which repositories for Helm charts you can use, which is like specifying which YAM mirror you can use if we're talking about Linux, right? But when you download the default one, it will work. However, being the default one, it wouldn't contain any information about how to monitor your environment. And then you need to design your own scrapers and do a bunch of those things. When you use a private chart like our own, it was already modified with all of the settings that it needs in order to monitor our own environment, which is super cool. And I guess there are pretty much a lot of charts that you can download from the internet that would include some kind of default settings for Kubernetes monitoring, but ours is not just that. It's also custom tailored for ITOM Platform. So that makes it a little bit more convenient in use, but less convenient in installing, because right now you see what we did. We had to download the chart, we had to install Helm, we had to generate download bundles, modify files, download the images, upload those images to local repository, all of those things, instead of running a single command, which is possible. But then after you run the single command, there's a lot of customization that you need to do, and it takes a lot more time, rather than using a ready solution that's already there and wasting more time on actually getting it to your own environment, right? So you win, you lose. It's all a matter of what is the task at hand. All right, it's done. Everything is here. So what would be our next step? What would be the next thing for us to do? is to actually create a NFS storage folder for our Prometheus. And I have a single command here based on scripts for setup NFS, and it's based on the notion that you create local storage. Okay, so it says, well, NFS is already installed because this script includes the steps for installing NFS on your server and configuring it, but also the step of mentioning what would be the storage name. It kind of creates the storage as well. So it created it on the local host. If it would be a remote NFS, of course, you'll do a new directory and then you'll modify your exports or something. Or I don't remember the file name, but you'll modify the file name so it would be coming up automatically with a basically a little bit of a different procedure, but still gets the same thing. Okay. So another thing, well, we created the storage or location for storage in our local NFS, but now we need to introduce the storage to our Kubernetes. And this is done by creating a new YAML file, and I'm going to call it Prometheus storage, right? And I already have this whole thing prepared, so I'll just copy paste it. But basically, this is just simple YAML file structure, which says, well, what kind of API, what I'm creating, that's going to be persistent volume, that's an entity in Kubernetes terms. And then the metadata, like what's the app, what's the name, and what are we doing with access, how much storage am I allocating, and where, most importantly, where it's located, and what's the name of the server, right? So basically, all the defaults that would apply to any Kubernetes that you have, any Kubernetes cluster, of course, it would change, but things like Prometheus and ITOM Monitor are custom tailored for the Prometheus shards that we're using. So that's fine. As you see, if you know your Kubernetes, probably wouldn't have any problems with designing your own document for that. Okay, so now I'm going to create the entity in Kubernetes based on this YAML file. So that's more or less how you do it. Save config true. It means that it would load itself every time that we restart our Kubernetes, and then just the file based on which we do it. Okay. Another thing for us is to create a secret for Grafana. So Grafana would be accessed with this secret, and here's the password that you cannot use anywhere but my environments that are not exposed to the internet. So good luck with that. Right. So, but it's going to be the admin and some kind of a demo password. And when we generate the secret, now it can actually, when applicable, attach it to the specific pod that would be looking for it. Okay. And now we are going to install a Helm chart. So doesn't look like much over here. So while it's doing it, let's explain what's going on. Helm install CDF Prometheus. Basically, we're telling Helm to install CDF Prometheus, which corresponds to the image set that we have in local repository. In case there wouldn't be a local repository, no images in the local repository with those names, it would go somewhere to the internet, assuming that it knows how to get there, and download stuff for you. Okay, so generically speaking, let's say you could do it with a remote repository as well. But our way was more convenient because we were in full control and our method is applicable for offline kind of operation. But definitely you could use Helm install CDF Prometheus and then specify the remote registries one way or another, but that would just complicate everything. Okay, and then we just specify what is the namespace, where to put your stuff, where is the chart to use in order to even to understand what I'm asking from it to do. Okay, and then just put where's the where to put your stuff, and what organization name that more or less refers to the particularities of our ITOM platform. So basically, we just tell it to install something from the local repository. That's the gist of it. And let's see if the pods are up. So they sit in the core namespace. So we'll do just that. K get pods, not pods, get pods -n core. And there we'll see it. CDF, Prometheus, Grafana, ITOM Platform, everything of this sort is over here. So it's running, but this one, Prometheus CDF, Prometheus CDF dash Prometheus dash Prometheus dash Prometheus dash 0. What an this is very unfortunate pod name. But yeah, it's still container loading, so let's see if it's still there. And it's running, I think I can access it. So the way to access it, you basically specify the management portal URL and port, and just add Grafana to it. So let's do just that. We'll go to our HTTPS master itom.com. I'm very original with my domain names, aren't I? Okay, 5443/Grafana. And if everything works correctly, we should see, first of all, this warning which loads really slowly. What's up with that? Why is it so slow? No, oh, come on, no. Okay, we click on advanced and we accept the risk and continue, because self-signed certificates are not really a thing that browsers like, right? And then we'll go to admin and put the password that we put in our secret previously, and I'll save it because why not? That's my demo password. Okay. And now we know that in Chrome it works much better. Because in Firefox it lags a little bit, which is something that is not expected. So let's see if it already got the settings. Sometimes you just need to wait a little bit. So, oh, there we have it. So this is Grafana. They really like black dashboards. It's just a thing. Ah, those black dashboards. And yeah, that's what we have. I don't know what to do with all this information, but we have it. But we have it, and we can look at pods. Let's see pods. What's going on with my pods? Okay, data source. Oh, and I can isolate pods. So I'll go and I want to see what's going on with my receiver for Kosovo, and it's not really busy. There is some kind of busyness to it, but not really. So we can break it down. So there's like a lot of insight into this thing. And of course, people might ask, wait, but your Kubernetes provides those information by default. And that's true, but that's a little bit more convenient in terms of access, more modern. So this is what I'm talking about. So if we'll go to the Kubernetes default platform, it too has dashboards. So let's stop for a second to review them. I know that the video becomes really long, but what can you do really? Oh, password expired, but of course. Okay, so come on, just 1 second. I'm just preparing the copy pastes of this password here on the side, just to speed up the process. Modifying, always change your things in IDM. Don't let it expire every 3 months if it's your demo environment and it's in secured location. Okay, so basically I think we go to dashboard in the cluster. All right, slash dashboard, that's all I needed. Yeah, I could access it directly. Okay, so we'll look at the same namespace as Grafana does, right? And I can go to pods and I can select a pod. So here we selected what? DI receiver. Okay, DI receiver it is. ITOM DI receiver deployment. I'll click on it, and what do I get? I get several parameters here and there, but not as many as I really want to, right? And I think maybe there is a way for me to dive inside. I think I think there are more ways to do it, but definitely, yeah, we got the CPU, we got the memory, but not on the same level as Grafana here. And I don't know why it's reloading at the moment, but we got the point, I think. I think we mostly got the point. Yeah, so it gets more insight into the same information, and using some kind of templating, probably it can access the same resources. So yeah, more data. Let's see how my nodes are doing. And my nodes are, where are my nodes? That's my nodes. Okay. And there's one node and another, right? I think. Right. So it says instance. Do I have two of them? I do have two of them. Although it's using its internal addressing, so it's a little bit more difficult to distinguish, but still. One of them is a worker, another one is a master, and fantastic. So this is a fun overview of what it can do for us. Maybe it deserves a video of its own, actually, just to play with this thing. But that's not the point. The point is, what do I do now? Well, now there are a couple of things for us to do. Okay, so let's address them one by one. First of all, right now, I can access this with the /Grafana thing, but it doesn't mean anything to us when we try to access it from outside. Okay, and mostly I'm talking about Prometheus. So I cannot access the Prometheus from the outside right now. Now it doesn't matter how I try. So I need to create a new service that exposes Prometheus.